Hi everyone, welcome back to the channel. Today, we're diving into my journey of recertifying for the AWS Solutions Architect Associate Exam SAA-C03. Yes, it's that time again. AWS certifications only last 3 years, and let's face it, the cloud moves faster than a hyperplane request. This was my third time taking the exam, and trust me, it's packed with some exciting updates. Having aced the SAA-C03 and its previous versions, I'm here to give you the ultimate cheat sheet to crush this exam. From must-know topics to key technologies, I've got you covered. So buckle up, because by the end of this video, you'll not only know what to expect, but also feel ready to knock this exam out of the park. Take your AWS skills to new heights. Let's get started. So let's start off by talking about the exam format itself. So it is an associate level exam. So this is one level up above from the foundation level, but it's not the specialty or professional level. It is an associate level, which means it gives you a thorough grounding across the AWS ecosystem on core services, features, and in the case of the solutions architect, it's designed to help you think like a solutions architect. The exam duration is 130 minutes, which is spread over 65 questions. These can be multiple choice and multiple response style questions, and I'll talk more about that in a second. It's $150 that you need to pay, and you would usually book the exam with Pearson VUE Testing Center, or you can do it online at home under proctored conditions. So let's talk about exactly how those questions are formatted. So you'll definitely get multi-choice style questions, which will include a scenario-based question and 4 answer options, and you need to select one answer. This is your typical MCQ style question. You then have multi-select questions. Now here what happens is you get a scenario, and usually you are expected to resolve the issue or come up with a solution that will be a combination of a minimum of 2 different tasks that you must perform. Okay, so you'll need to select 2 answers from the 5 options that are available. Now, up until recently, this used to be this typical exam style questioning. You get the MCQ questions, which has got 4 answer options, and you select one, and then you get the multi-select, which has got 5 answer options, and you select 2. That seems to have changed, because now we've got a new multi-style questioning format where you actually get 6 answer options and you need to select 3. And usually these questions are a lot harder because they require you to have perhaps had some experience in working with that piece of technology. So when you're preparing for this course, be sure to get onto the hands-on labs and exercises as well, and actually play with the AWS ecosystem so that you get that practice that is necessary for the exam. Now, in order to pass the exam, you need to get 720 points out of 1,000. Now, of the 65 questions you get in the exam, 15 of those questions are unmarked, and they allow AWS to introduce new questions and get feedback as to how those questions are being answered. Do not waste your time trying to figure out which ones they are. They all count when you're sweating in the exam. So just ignore all of that and just focus on ensuring you get every single answer correct. So answer all the questions in the exam. Next, I want to talk to you about how to read the question. So every question is going to be scenario-based, designed to test your real-world problem-solving skills. At the end of the day, this is a solutions architect exam, and as a solutions architect, you're supposed to come up with solutions. Now, when you're reading the question, you must try and identify the criteria or the filter of the question. Usually the question would have some sort of filter, some sort of criteria based on which you need to deliver your solution. So for example, here's a question. Which option enables you to ensure the most cost-effective solution for hosting the proposed static website? Answer options are EC2, S3, RDS, or DynamoDB. The filter or the criteria is that whatever solution you come up with must be cost-effective. That's your evaluation criteria. That's ultimately an important element of the question that you need to take into account, and you need to make sure that your answer aligns with that criteria. Next, the kicker is the recognition that hosting a static website does not require you to use compute resources like EC2 and can be more cost effective when handled by Amazon S3, for example. But I want you to focus on the criteria as well as obviously the keywords. The keywords here, or the kicker here, being hosting the proposed static website, but the criteria should be one that is of paramount importance when deciding how to answer the question. So when it comes to looking at criteria across the various questions that you see in the exam, here are some examples. You will find questions that try to get you to identify a solution that's going to be most cost effective. Another one is least administrative overhead. So where they need to make a change to a particular system or an architecture, but they don't want administrative overhead. Most secure. This is really, really important. This is one where based on the answer options, you want to select the option that is going to give the maximum level of security. Least effort. This is another one of those criteria where perhaps you're doing a migration or you're moving applications from on-prem to the cloud, and you want to do this with the least amount of effort. So essentially meaning that you don't want to make changes to the application. Highly available or scalable is another area that you'll find a lot of questions on. And so this is one where you want to make sure that the solutions you select, and these are usually the multi-select type questions, that the options you select will ensure high availability and scalability. And then there is solutions where the application architecture cannot be changed. So that's similar to the least effort element as well, where you're making a change. Perhaps you're doing again yet another migration and you can't change the architecture of the application. So you need to use similar services that were being used on premises, for example. Finally, you may also find a lot of questions that are migration focused. As solutions architect, you're going to help a lot of clients move from their on-premises workloads to the AWS platform. So now I want to move on and take a look at some core topics that you need to really understand and study in order to prepare for the exam. This is critical to the foundation of security on the AWS platform. Remember, there will be a lot of questions that will get you to set things up with the least administrative effort and the most secure. So using IAM and the various identity and access management services is going to be critical in your design patterns. So let's take a look at IAM. So with IAM, you need to be aware of IAM users, IAM groups, and IAM roles. And obviously, you know by now, hopefully, if you're watching this video, that these are three critical elements that allow you to enable authentication and authorization within the AWS platform. You add permissions and policies to users, groups, and roles, and you will grant those different principals access to various services and resources on the AWS ecosystem. Now, another key factor, and you'll see this in the exam, I guarantee it, is that, as Tom suggests, IAM roles are often more secure than access keys. So if you see any questions that are trying to compare access keys instead of IAM roles, well, you know that's not really the case. In most cases, it's going to be IAM roles that will be the recommended approach. Why? Because you know for a fact that IAM roles grant temporary credentials. You don't have to rotate keys or passwords because these are managed by the security token service. These are important things to remember for the exam. Also, another service on the AWS platform is the Identity Center, which is the Workforce Identity Service. Previously, it was known as the Single Sign-On Service, or the SSO. The good thing about this is it's designed to help you build your workforce identity so they have access to a wide range of accounts within your AWS organization. You know for a fact that AWS organization enables you to build a multi-account architecture. You can have different accounts for things like different environments, dev, test, UAT, and production. And you want to make sure that users who need access across multiple accounts don't have multiple credentials to remember. The Identity Center can help you address that requirement. Even better is the fact that you can actually incorporate your identity provider that is located on premise, for example, Microsoft Active Directory, as your identity provider for the Identity Center. So all of your users can actually have Active Directory accounts, and that will be federated into the Identity Center to allow your users to use their existing Active Directory accounts to log on to the AWS platform and the AWS accounts in your organization. Makes things a lot easier, ensures less administrative overhead, and obviously the security aspect of it. Okay, so next, let's take a look at storage. Now, storage is a really important section of the exam. It covers object, block, and file storage services. And we'll start off by taking a look at object storage services. And obviously, the key hero over here is the Amazon S3 service, which offers object storage services on the AWS platform. Now, when it comes to object storage, this should be, in fact, your default storage option. Unless you need block storage to attach to your EC2 instances or file storage for sharing files between your EC2 instances, object storage is really the solution that you would have for most of your storage requirements. Critical for the exam is remembering and understanding the key use cases for all of the different storage classes that you have with the Amazon S3 service. For instance, if you're not sure of the access pattern for your data, intelligent tiering might be the best option. If you're storing secondary copies watch out for that phrase, secondary copies of your data, which means you obviously have primary copies somewhere else, then you might want to reduce your cost and store them in one zone IA. And obviously, if you've got archival storage, then the cheapest archival storage on the AWS platform is the S3 Glacier Deep Archive. But be warned, you do need to spend a lot of time in order to get access to that data, so it can be up to 48 hours before you can get access to that data. In addition to the storage classes, you should also be aware of the S3 object lock service. This allows you to place data on legal hold, where you want to ensure that no changes can be made to the data that's written to the bucket. Using the worm terminology, which is write once, read many, you can use object lock in order to secure your data for legal hold purposes. Let's also talk about lifecycle management, which is a critical feature if you want to manage cost of storing data in the cloud. It allows you to transition data between your storage classes where it may be more cost effective because of the access pattern to put them in one of the infrequent access storage classes or the Glacier storage classes. You can automate that transition and ultimately the expiration of your data when you no longer need it. And then let's not forget about S3 static website hosting, which is a feature that predominantly is used in a lot of serverless-based application for your front-end application user interface. So in a nutshell, that pretty much covers Amazon S3. Now let's talk about the storage gateway service, which is a service that you would use to build hybrid cloud solutions between your on-premise storage requirements and the cloud. Many organizations will migrate data to the cloud, but would still want to maintain data on premises for things like local access, ultra-low latency, and perhaps some compliance requirements. Now the storage gateway helps you build that hybrid cloud storage solution between your on-prem data center and the AWS platform. And it offers several different types of storage gateway options. You've got the stored volume and the cached volume. The cached volume is where you want the bulk of your data sitting in the cloud, but have a subset of your data hosted on-prem, allowing you to maintain minimum amount of storage devices. The tape gateway is also another feature that is often used by many customers. Yes, there are still customers who like their old backup software that uses a tape drive mechanism, and you want to migrate them from their physical tapes to virtual tape architectures, where the data actually sits in S3 but presents itself as virtual tapes to the application. And let's not forget to mention about the file gateway options, which gives you direct access to data stored in S3 using file protocols like SMB and NFS. And ultimately, using the storage gateway gives you that hybrid link between on-prem and the AWS S3 platform. Next, let's talk about file storage services, and we've got two of them. We've got the FSx for Windows File Server Share. Now, this is where you want to use file server solutions for Windows-based systems using Windows technologies and services. The ability to integrate it with Active Directory, use DFS, distributed file system for your access requirements, and tightly integrated with Windows-based components and services using SMB protocols is where you might want to use the FSx for Windows File Server System. This is a file server solution on the AWS platform running Windows operating system that is fully managed by AWS. In case you need a file system for Linux-based system, we've got EFS. EFS allows you to build file system solution where you can create file systems that can be mounted onto your Linux-based operating systems and your Linux-based EC2 instances. Again, you can access this file system from on-premises location using VPN or Direct Connect services. And of course, let's not forget about the EBS service, the Elastic Block Store service, which is where you can spin up volumes and attach them to your EC2 instances as the boot volume and data volumes. You can create snapshots, and you can use the data lifecycle management to manage the lifecycle of your EBS volumes. It's very important that you actually understand the differences between the general purpose volumes and the provision IOPS volumes. These are SSD volumes, and then obviously you've got the hard drive volumes, the HDD volumes as well. Now remember that the general purpose and provision IOPS SSD volumes are the only type of volumes that are bootable. The HDD volumes are not bootable. Finally, make sure you also study about the S3 on Outpost, which allows you to host S3 buckets on premises using the Outpost infrastructure. And then let's not forget about the Snowball service that allows you to migrate massive amounts of data up to petabyte in size from your on-premises location to the cloud using offline measures using the Snowball devices. These Snowball enclosure disk units that come in different shapes and sizes. So you've got the Snowball Edge and the Snowcone devices that you can use to migrate data to the cloud. Finally, let's talk about AWS Backup, a service that allows you to manage the backup of all of your different data services on the AWS platform, including backing up data from things like RDS databases and your EC2 instances. Okay, let's move on and talk about networking next. What you're looking at on the screen is a typical virtual private cloud designed with best practices in mind, specifically along the lines of the fact that we're going to be spreading our workloads across multiple availability zones, and we're separating out our public subnets from our private subnets. Your public subnets needs to host only those resources you're happy to expose out on the internet. Everything else should be in private subnets. We're separating out our web tier from our database tier, and we're ultimately building a 3-tier architecture. Your VPC will need access to the internet, which ultimately means you need to deploy an internet gateway. You'll also need to deploy a NAT gateway to facilitate internet access for resources that are hosted in the private subnets. Those resources will use the NAT gateway as a proxy to get access to the internet, but continue to have private IP addresses and therefore not directly exposed out onto the internet. Now, in addition to that, don't forget that your VPC needs to be configured with route tables. Route tables define exactly how traffic flows within the VPC and externally to other external networks, be they the internet or other VPCs or other areas of the AWS ecosystem. You've got your main route table and your public route table. You should really have a separate route table for your public subnets. In this case, we've defined it as the public route table. In addition to that, you will also be configuring network access control lists. These protect the subnet and act as a firewall solution for your subnets, ensuring that you allow only specific traffic inbound and outbound to those subnets. Network access control lists also help you to define inbound and outbound rules in a stateless fashion, which means that you have to define both the inbound rules and the corresponding outbound rule for traffic to flow bidirectionally. Furthermore, when you're setting out outbound rules for your resources that are hosted in those subnets, your network access control list must allow ephemeral ports. These are the higher port ranges because you are not sure of what port is being used by the end client. Another thing to bear in mind with network access control is that you can use it to deny traffic from specific sources where you may have a blanket allow for most resources. So what I'm trying to say here is that, let's say for instance you allow inbound traffic on port 80 from the entire planet, but there's a particular IP range you want to block from accessing your resources on port 80, that can be set to an explicit deny. You then have security groups, which are stateful firewalls. These firewalls protect the actual instance and they are applied at the instance level. More precisely, they apply to the Elastic Network interfaces attached to those instances, be they EC2 instances, containers, or Lambda functions. You need to be aware of the fact that security groups are the default security firewall solutions for your EC2 instances and for your compute resources. Network access controllers are considered the backup firewall solution. Also, the thing with security groups is that you can only define allow rules. You cannot define any deny rules. If you need to define deny rules, you must set up network access control list as well. Interesting enough, AWS will still test your knowledge on NAT gateways versus NAT instances. NAT instances used to be the precursor to NAT gateways, where you would spin up EC2 instances, disable the source and destination check on those instances, and install or use an AMI that came with the NATing software. By and large, that carries with it a lot of administrative overhead. So if you want to reduce your administrative overhead, then you need to go with NAT gateways. The only time you would be using NAT instances is if you had some strange port forwarding rules that you needed to set up. When it comes to cost savings, understand the fact that any data that moves out of an AWS region, whether it's to other regions or to your data center, is going to be chargeable. Also, quite often you'll see a lot of questions that want you to ensure security so that traffic from certain resources in the VPC doesn't traverse the internet. Now, by and large, if any of these resources need to access the internet or any other services on the AWS platform, currently in this configuration would make use of the NAT gateway, which means that traffic goes out to the internet and then kind of like comes back in again into the AWS public zone to access things like S3, DynamoDB, and so on. If you want to ensure complete privacy of that traffic, if you want to ensure that that traffic does not traverse the internet, make use of endpoints. Gateway endpoints and interface endpoints. Make sure you know the key differences between these two types of endpoints. Specifically, for Amazon S3 and DynamoDB, you need to set up what are called gateway endpoints. Everything else is interface endpoints. What this basically does is it allows you to have resources in your VPC access services in AWS like Amazon S3 over a private link connection. using the AWS Backbone network, and offers two key benefits. One is cost-saving strategies, and the other is obviously security. We also have the ability to connect multiple VPCs together using the VPC peering capability. And then obviously there is the VPN connection service, which is the IPsec VPN tunneling service that allows you to connect your on-premise data center to the AWS VPC using a customer gateway located on the customer side and a VPN gateway located on the VPC AWS side. So the VPN gateway service allows you to connect your on-premise data center to the AWS VPC in your AWS account and establish a private tunnel over the internet. You can also set up direct connect, which will give you a higher bandwidth. And that connection is actually totally private in the sense that it does not traverse the internet, but you will need to lay down fiber optic cabling between your local data center and a local direct connect partner to get into the AWS network, and therefore is a lot more costly. There's the AWS Transit Gateway that allows you to configure multiple VPCs to connect to each other, including on-premise data centers using a hub and spoke model, which reduces administrative overhead. And then there's the AWS Global Accelerator service that allows you to publish your applications across multiple regions using static IP addressing, using the Anycast IP addressing setup. You also have AWS CloudFront, which allows you to build a content delivery network to publish your applications and act as a front-end entry point to your applications, be they hosted on Amazon S3 or EC2 instances. CloudFront makes use of edge locations to allow you to distribute your content and cache your content locally at edge locations. When it comes to cost-saving strategies, you may wish to reduce the number of edge locations that your data is cached in based on where your customers are based. There's Amazon Route 53, which is AWS's DNS service. Make sure you understand very clearly what are the different routing policies. So you got weighted routing policy, latency-based routing policy, failover routing policy, and so on, and exactly where you would use those policies. Next, let's talk about compute services. So we've got compute services, EC2 instances that you would deploy by choosing an AMI. You can bake your own custom AMIs, or you can choose AMIs from the AWS ones that are provided, or community AMIs, or purchase them from the marketplace. You would use the AMIs, which would help you deploy your EC2 instances, and obviously you can then attach block volumes to your EC2 instances. Using various configurations, you can then set up web servers, database servers, application servers, and so on. And ultimately, you would also attach any IAM roles to those instances so that they can get access to other resources and services on the AWS platform, like S3, DynamoDB, RDS, and so on. So for the exam, understand how you can create snapshots, understand how you can create these pre-baked AMIs, these golden images as some folks like to call them, and how AMIs are used to manage your EC2 instances to speed up the deployment of your EC2 instances. Don't forget that you can copy AMIs to other regions. So if you're in a multi-regional configuration, you can have your AMIs available in other regions as well, which needs to be the case if you want to use those AMIs to be spinning up EC2 instances. Next, let's talk about exactly how you purchase these instances. So we'll talk about pricing option, which is a fundamental area for cost-saving strategies. You have the standard default method of deploying your EC2 instances, which is the on-demand instance type. This is where you would deploy workloads that are short-term workloads, unpredictable workloads, and workloads and applications that cannot be interrupted. You have reserve instances for long-running workloads where you can benefit from volume discounts if you go for the standard or convertible instance type. Bear in mind that the convertible reserve instance gives you a lot more flexibility, but then you cannot sell those on the reserve instance marketplace. Spot instances are where you can bid for available capacity on the AWS platform and get up to 90% discount. Spot instances are ideal for batch workloads, image processing, data processing, but the important criteria is that the applications can be interrupted and therefore are stateless and will not be affected by any kind of interruptions. Should the spot price go above your market price, the price that you are offering, AWS by default will terminate your spot instances. On-demand capacity reservation is an alternative to reserve instances where you may require reservation of capacity because you want to make sure that the capacity is available when you need it, but not necessarily for that very long-term period. Savings plans is another great way of cost saving on the AWS compute services, you have two different types of saving plans: EC2 savings plans, which can give you the maximum discount but only apply to EC2 instances. Then there's the compute savings plans, where you can fix a dollar amount that you committed to, which will be used to give you reduced discounted rates against all compute resources across Fargate, EC2 and Lambda. When it comes to managing and accessing your AWS EC2 instances and bulk administering them, you can make use of the AWS System Manager service. Parameter Store allows you to retrieve parameters that you may need at runtime for your applications. Session Manager allows you to make SSH connections to your EC2 instances in a much more secure manner, avoids the use of using jump boxes or opening ports. And the run command allows you to run a command against multiple EC2 instances in one batch. Let's talk about high availability and scalability. When it comes to EC2 instances, you can use the auto-scaling service to scale out and scale in. Make sure for the exam you understand the key differences between target tracking, step scaling, and schedule scaling policies. When it comes to high availability, you've got the application load balancer, which will allow you to distribute traffic at the application layer. So that's looking at the HTTP and HTTPS protocol. If you require TCP UDP connections and you require millions of requests per second, you need to be able to handle those, or you need static IP addressing, consider network load balancers. You may even be in a situation where you can use both the network load balancer and the application load balancer. The application load balancer can be a target for the network load balancer in your configuration. Don't forget the gateway load balancer. Make sure you read up on that and understand what the use case for that is for the exam, and also learn about placement groups for the exam. So you've got three different types of placement group. You've got the cluster placement group, where all of the instances are located in one availability zone. You've got spread, and then you have partition placement group. So make sure you know the key differences between the three. And then let's talk about containers. So with containers, you've got Elastic Container Service and Elastic Kubernetes Service. So if you're trying to migrate Kubernetes clusters from on-prem to the cloud, then the EKS solution might be the better option. ECS is if you want to deploy containers using container images, Docker images. You can have two types of ECS services or EKS services. You can either go for Fargate, which is a serverless approach where AWS will manage the underlying infrastructure, or you can go for the EC2 launch type where you manage the EC2 instances yourself. Amazon ECR is the Elastic Container Registry to store all of your container images. Finally, let's talk about Lambda. So Lambda is an event-driven compute service. It needs to be invoked, usually in response to an event or on schedule, and it can interact with other AWS services to help you build a complete end-to-end serverless architecture. Accessing the Lambda function can be done via the internet using things like the API gateway. The API gateway acts as a front door for all of your API calls. Your APIs that you build can either run off Lambda functions, EC2 instances, or even containers. But when it comes to the API gateway, remember some key features like the throttling service to avoid over excessive requests coming into your AWS environment, and the caching services as well to help you, and the caching services as well. Remember, when it comes to Lambda, ECS, or containers, you're always going to need to make use of IAM roles, predominantly because your applications running on those compute resources may need access to other services and resources on the AWS platform across other technologies like S3, DynamoDB, RDS, and so on. Right, the next topic that you really want to cover is databases. This is also heavily tested on the Solutions Architect exam. The focus is obviously on the RDS database, where you need to understand how to build for high availability and scalability. Multi-AZ gives you high availability. You get a primary instance and a standby instance that it fails over to in the event of a disaster or a reboot or whatever it is. And you also have an additional type of multi-AZ configuration, which is known as the multi-AZ DB cluster, that gives you two standby instances instead of the one. This can be spread therefore across three availability zones ultimately. In addition to that, when it comes to scalability, remember that RDS databases work differently. You only have the single writable instance in an RDS configuration, unless you start getting all complicated with shards and stuff. But ultimately, because you only have the one primary instance that you can write to, you can scale read replicas. You can scale out to have read replicas, which ultimately means that you can get your application to perform all read queries against those read replicas and thereby reduce the load on the primary instance. The next thing that you want to be aware of for the exam is the RDS proxy service, which basically allows you to improve application availability, scalability, and security by efficiently pooling and managing connections to the RDS database. And then let's talk about backups. It's all very well having multi-AZ to give you high availability, but you still need to make sure you do regular backups. Okay, and you've got two types of backups. You can have automatic backups, which you can configure on the actual database itself, or you can perform manual backups as and when you need it. Now, when it comes to automatic backups, you have a retention period of anything from 0 to 35 days. You can have up to 100 manual backups per region, and snapshots can be copied across region. Now, the good thing about that is that you can create a snapshot, copy it to a different region, and your colleague on the other side of the planet in their region can basically spin up a database from that snapshot. It's good for disaster recovery and more. Be aware of the fact that when you have all these backups, your manual backups and your automatic backups, that's going to increase your cost. So consider deleting backups for cost-saving strategies. Also, one thing to note is that you can only retain automatic backups of DB instances, not multi-AZ DB clusters. When you shut that database down, when you actually terminate that database, you can retain the backups. Let's talk about Secrets Manager. Secrets Manager is a brilliant service to help you manage your database credentials. It also helps you rotate your database credentials on a regular basis. Your application can then communicate with Secrets Manager, dynamically retrieve those credentials to access the database. You do not need to save your credentials in your application code in plain text. Amazon Aurora, another service that's heavily tested in the database section on the exam. Make sure you know the use cases for Aurora serverless. Things like variable workloads, multi-tenanted applications, and capacity planning is another key feature of Amazon Aurora. As a solutions architect, you probably see a lot of questions about how you would migrate your on-premise database to the cloud. So you've got two types of migrations you can perform using the database migration service, or DMS. You've got homogeneous migration, where you can move from Oracle to Oracle, for example. Or if you need to do heterogeneous migration, you want to migrate from MySQL to Oracle, then you need to use a tool called the SCT, or the Schema Conversion Tool, before you use the DMS service. You can also use the DMS service to make ongoing changes on your source database replicated to your destination database in the cloud. Elasticache. Elasticache is an in-memory caching service that gives you access to two in-memory caching engines, Redis and Memcache. Redis is for more complex data structures, Memcache for more simple ones. Make sure you read the key differences in the AWS documentation between Redis and Memcache before you enter that exam room. DynamoDB is also another database that's tested on the exam. Now, not so heavily when compared to the Developer Associate certification. You get a lot more questions on DynamoDB there. But in the Solutions Architect exam, understand the core principles of DynamoDB. Its structure, the fact that it's NoSQL, its write capacity units versus read capacity units, and also understand the features like global tables, DynamoDB DAX, which is a caching service, and obviously DynamoDB Stream. Let's move and talk about security, and the first thing to look at is obviously going to be encryption. Now, with AWS KMS, Key Management Service, you can build your encryption services to encrypt data at rest. Bear in mind that you've got two different options. You've got the option to use the standard AWS managed keys for your various services. Like, for instance, if you've got block storage volume, you can use the AWS managed keys for EBS, or you can create your own customer managed keys that allows you to get more flexibility in the keys that are used to perform those encryption and decryption services. In addition to that, let's talk about S3 encryption options. So with S3, you've got several different types of encryption options. There's server-side encryption with AWS S3 managed keys, server-side encryption with KMS. This gives you additional flexibility and features in terms of the fact that you can audit the use of those KMS keys. Dual layer server-side encryption with KMS keys. Server-side encryption with customer provided keys, when the customer needs to provide the keys as a requirement of your use case, and then client-side encryption, where the encryption must happen on the client side before the data is sent into S3. In other words, S3 is not aware of the data itself. It's not able to encrypt or decrypt the data. All of the encryption happens on the client side. Protecting your data held in S3. One of the key fundamental security measures is you want to make sure that data stored in S3 is protected. Specifically, PII, personally identified information, needs to be protected. There is also personal health information that needs to be protected on the AWS platform. You want to make sure that that's the case, because the last thing you want is someone hacking into your S3 platform and being able to retrieve that data. And in comes to the rescue, good old Amazon Macie. Amazon Macie is a service that will actually help you protect your data and identify data that has PII information on AWS, and ultimately give you opportunities to mask that data so that it doesn't fall into the wrong hands. You can actually use Amazon Macie to give you alerts, build dashboards, and you can use it to identify data that needs to be protected. Okay, so let's talk about Cloud HSM. Now, Cloud HSM is for those customers that need full access and capability to create and manage their own keys and encryption services. Here you can control and protect your encryption keys with secure, compliant hardware security modules that's dedicated to your AWS account. Okay, so you're not using shared security models as you would with KMS. And this might be a compliance requirement for your organization. Okay, and then let's talk about Control Tower. Now, AWS Organization is a service that helps you manage and create a multi-account strategy. You can build multiple accounts, put them in different OUs for different use cases, environments, for example, or simply just for different business units, or however you want to structure your OUs, and then apply service control policies, SCPs, to control what services can be consumed in those accounts. Now, on top of all of that, you have AWS Control Tower, which is a service that basically automates the setup and governance of a secure multi-account AWS environment based on AWS recommended best practices. It comes with a series of different blueprints that you can use, and you can define exactly how your environment, your organization should be set up and configured. Next, we have AWS Firewall Manager. So AWS Firewall Manager basically simplifies the management of protection services like WAF, Shield, security groups, network access control lists, firewalls, and Route 53 Resolver DNS Firewall across multiple accounts and resources. You have AWS Network Firewall. Now, this is basically a firewall service that performs stateful managed network firewall designed to protect individual VPCs. So be sure you understand the key difference between what Firewall Manager is and Network Firewall. You have CloudTrail, which is a service that enables you to monitor, log, and retain account activity related to actions in your AWS infrastructure for governance, compliance, and operation troubleshooting. Basically, you can tell who did what when using CloudTrail. And then you have Config. Config is a service that enables you to assess, audit, and evaluate configurations of your AWS resources, provide visibility into resource configuration, and changes for compliance and security purposes. Next, let's talk about application integration. Now, when you're building applications, you can either build monolithical applications or you can build applications that are decoupled as microservices architectures. The shift from monolithical structures has become extremely important. We want to be able to have distributed systems. We want to be able to decouple our application stack so that we don't have single point of failures. Let's take a look at queuing systems that are often used to help us build decoupled applications. There's the Amazon SQS service that allows you to build both FIFO queues and standard queues. These queues are designed to hold messages between different components of your application. You might have a front end and a back end, for instance. The front end request can be held in the queue. The back end will poll the queue to retrieve those messages to perform certain requests as and when it has capacity. This polling feature and the ability to store messages in the queues allows you to decouple the front end from the back end. For Amazon SQS, make sure you understand the key principles around visibility, timeout periods, dead letter queues, long polling, and the fact that the data held in the queue is there for a maximum of 14 days. Amazon SNS is another type of application integration service, whereas SQS was all about queuing and poll-based messaging platform, and it allows you to decouple your application stack. Amazon SNS is a pub sub push-based notification service. Essentially what happens is messages that go to SNS gets pushed out to a topic, which then gets consumed by subscribers to that topic. So you can have subscribers like Lambda, SQS, HTTP, HTTPS endpoints, email, and SMS. With Amazon SNS, you can also configure what is known as a fan-out processing, where you can have a single message fanned out to different subscribing endpoints. And then you should also be aware of the FIFO topics, which is a feature specifically designed for building connectivity with FIFO SQS queues. Amazon MQ is a managed message brokering service that supports open source messaging protocols, enabling seamless migration and operation of message-oriented middleware like ActiveMQ and RabbitMQ. Essentially, Amazon MQ is the alternative to Amazon SQS if you want to use your own existing message brokering service where you might be migrating your on-prem messaging solution to the cloud. And then we have EventBridge. EventBridge allows you to basically trigger events that will call various actions against services like Lambdas, SQS, and so on. And these events can be triggered based on an actual event happening or on a particular schedule. When an event occurs or at a particular schedule, you can trigger a rule to call a Lambda function, to send messages to an SQS queues, to send out an SNS notification, etc. Finally, for all of these services to work and integrate with various other services on the AWS platform, remember that you're going to need permissions. These are defined in the form of policies that are assigned to those services. Okay, let's move on and talk about analytics next. Now, this is an important area as well that you'll see quite a few questions on. So first thing is first, we'll talk about Kinesis. Kinesis is a real-time streaming service which allows you to ingest data from almost any source and then perform various analytics on it. So a stream is composed of one or more moving shards within your Kinesis service, and data is retained for up to 24 hours by default, but can be extended up to 7 days. You have write capacity capability at 1 megabits per second or 1000 records per second, and read capacity at 2 megabits per second for your data reads. You then have Kinesis Data Firehose. Now, this is near real-time loading of data into services like Amazon S3, Redshift, OpenSearch services, or third-party services like Datadog and Splunk. You use Kinesis Data Firehose for data transformation on the fly using AWS Lambda. Here's a quick tip. Firehose integrates with other services like AWS Glue Schema Registry for schema validation. Okay, so next is Amazon Athena, which is a serverless interactive query service that allows you to analyze data held directly in S3. You don't need to build any kind of infrastructure, which makes Athena really powerful for ad hoc analysis. Schema must be defined using either the AWS Glue data catalog or provided inline whilst running the query. So it's fairly easy to run. You simply define the schema for your data and Athena will be able to analyze the data for you. There's Amazon EMR, Elastic MapReduce, which is a managed big data platform for processing and analyzing large data sets using open source frameworks like Apache Hadoop, Spark, Hive, Presto on scalable EC2 instances. And then you also need to be aware of Redshift, which is our data warehousing solution. Now, in addition to Redshift, you also have Redshift Spectrum, which does a similar kind of thing to what Athena does in the sense that it will allow you to query data directly held in S3 using Redshift SQL queries without needing to load data into Redshift tables. But what it does do is it provides you with integration into Redshift. So you need to understand the difference between using Redshift Spectrum and Athena. Athena is serverless for querying S3 directly, but Spectrum works with Redshift for combining data from S3 and Redshift. Couple of quick tips as we end this session. So understand the difference between Kinesis Data Stream and Amazon SQS for messaging use cases. Okay, so one's for streaming, the other is just for decoupling your application stack. Understand the difference between Athena and Redshift. Remember that Athena is serverless for ad hoc queries, whilst Redshift is for managed data warehousing solution. Okay, so last but not least, you need to learn the well-architected framework. Now, the well-architected framework consists of 6 pillars: operational excellence, security, reliability, performance efficiency, cost optimization, and sustainability. Understand these 6 pillars really clearly and how they apply in helping you build real-world solutions. Remember, you want to design your solutions that are aligned to the well-architected framework, so make sure you study these really carefully. So to sum up, this exam is all about applying architectural design patterns from the AWS well-architected framework. Focus on the fundamentals of cost optimization, security, scalability, and efficiency. And here's the good news. You've got this. If I can recertify after 3 years, so can you. Remember, study the concepts, practice the scenario-based questions, and stay calm during the exams. Good luck, and don't forget to like, subscribe, and share your experience in the comments below. I'll see you folks in the next video. Thank you.